So precast pavement has been around, let's say, since about 2000, 2001. We did our first large project in New York, but that has always been placed on an aggregate base. And we have done significant testing, as Stephen knows, and some other folks here. So when I got this call about using it for this location, I'm like, what? Anyway, here we are, and I'm very excited to have a part in this thing because it really did work very well. So you're going to have to bear with me to make sure that this works, and I don't think that this advances. Oh, yes, it does. Sorry. Look, okay, so by this time, and I'm going to have to look up here because I don't remember all these slides. By this time, you know the project participants, so we'll talk more about that later toward the end of the presentation. The slabs themselves, the precast slabs themselves, were actually fabricated in Mitchell, Ontario by Armtec. Armtec is one of the largest, as most of you probably know, one of the largest infrastructure companies in Canada, making precast products of all sorts. Corrugated steel products and also high-density polyethylene products. Armtec became a formal licensee of Fort Miller within the last year or so. This was one of their first jobs since then. They actually have produced slabs for a number of other projects over the last several years. But this is the first one as a licensee. So they took a major role in this. The slabs themselves were, as I said, manufactured in Mitchell, Ontario. That's located about 200 kilometers from Barrie. That's not very close. In fact, all the slabs have to be delivered during the daytime and parked along the side of the road until they were ready to use them. They actually have about 100,000 square feet of manufacturing space in this particular location, serviced by 2 concrete plants. Okay, so one of the big advantages, as you all know, I'm sure, of precast pavement slabs is the quality that's built in to the slabs. They're inspected at every point. They're made in accurate forms. Testing, all the standard testing is done. And one good thing from your point of view, we get to keep all the bad slabs in our plant. So you get to get all the good ones. So there's a lot of advantage to starting out with a concrete slab that you know is good. It's going to last a long time. So here is the fabrication. This was a small project, so they made actually only 2 slabs a day. So you can see, and the caption on the upper left is wrong. So there'll be a few errors in here, as I said before. This was done at night over the last couple of nights. What you're looking at in the upper left-hand corner is a roller screed being used across the top of their forms. That's very important because we're looking for an accurate surface. That's the first thing that we want to see on our slabs. Over on the right is again, a wrong caption, but what you're looking at there is a broom for a micro finish, and in back of that there's a very unique device that actually Armtec developed to produce the tine finish. On the lower left is a stand. They take the slabs out of the form, place it on a stand so the guys can work underneath it and underneath the slabs and actually attach those gaskets. Those are 1-inch square foam gaskets that are actually glued to the bottom of the slab for the purpose of keeping the bedding grout and the dowel grout separate. A very important detail, and you'll see later as it's going down, you'll see those on the job site. On the lower right-hand corner are the trucks ready to leave the yard. As I said before, they had to be shipped during the day and arrive actually on site before darkness, and then during the night they were installed. So this is a plan view of the site. As Stephen said, there were 3 methods. On the left-hand side, the asphalt supported, the 8 slabs, then there were 7 slabs grade supported. That's our standard system that Stephen talked about. And then on the right-hand side were 8 slabs of grout supported, and you'll get to see actually how those work. So the importance of this is the milling and the milling. On the left-hand side, you'll see that if you look carefully, the asphalt was milled to about the same thickness as the precast slabs, 206 millimeters in this case. We did put leveling lists in the slabs in case we needed them. And the grade supported slabs underneath those, the asphalt was milled 12 millimeters more to 218 millimeters, as well as underneath the grout supported slabs. So one of the first things that we did, and that was the Thursday night before, in other words, September 15th, was do the surveying. I was not there, we were not there, but we did communicate with Dufferin to actually let the surveyors know what they had to do. So early on in the project, it was decided that on this particular project, we were going to use flat slabs. Now, that's important to know, as I'll show you in a second. So we did not require the surveyors to take an accurate XYZ survey of the actual site, knowing that we were going to use flat slabs. But we did ask them more for the purpose of recording it, of what the existing cross slopes were on this roadway. So if we're using flat slabs, they're going to go down one plane. So you start from one end of that installation, go to the other. We're expecting to lay down a flat plane, and you'll see what actually happened. Surveyors also had to lay out the transverse saw cuts. That's the longitudinal and transverse saw cuts. The beginning transverse and the end transverse saw cuts, and also the saw cuts at the end of each stage, each night for the temporary slabs. I'll show you that in a second. And then he also had to lay out the panel points, or the ends of each slab, because we set every slab to a mark. So probably you can't read this, but what the surveyors did is actually measure the cross slope, and you'll see that there's really quite a significant change in cross slopes just in that particular section of roadway. Now, when I talk a significant change, I mean fractions of an inch. We're looking for these slabs to be fitting within 3 millimeters, as Stephen said. So if there's a cross slope change, it's a big deal. So what we did is we actually assigned a design cross slope to each section, which was different for each section. And the milling machine, the theory was the milling machine was supposed to be dialed into that particular design cross slope for that section. So that's how we actually approach this job. So this is the first night of saw cutting. We did that last Thursday night, as I said. This particular operation is very important. The saw cutter can make or break us if they make saw cuts that are not straight. I have to say that this is one job where the saw cutters did a very good job. So that was the first good thing that we saw when we got there on Monday night. Okay, so you can see. Okay, so in this is the first section, actually, not the right number of slabs, but you can see that there's a saw cut at the beginning. That's the permanent transverse cut. And then we set 8 slabs in this case in the first section, and then we went 1 meter more to set a temporary slab that was used to protect the dowels for that one night. So that's the layout for the saw cut, for the saw cuts for the first section. This is the operation for the first night. Milling for stage 1, the asphalt supported slabs. So one of the things that they did, they had to do was to start at the right-hand edge, the shoulder edge, to do the milling. So they used the shoulder as the grade control for the milling machine. And then a skid steer mounted broom for cleaning up the millings after the milling machine was done. This really went along really pretty fast. They started milling actually on the first section at about, let's see, about 9 o'clock at night, and 9 o'clock the first night, 9:30. Took a little while to get started, but they had the entire section milled out. So that was 203 millimeters by 8 slabs long, and they had that milled out by about 11:15. So milling was not the controlling operation. During the second night that we worked, September, that was Tuesday night, basically they milled and they placed the slabs in stage 1. So one of the consequences of the milling operation was that at the very beginning we were left with you can see a little rounded section there that had to be removed. We were concerned about that during design. And then the same thing on the leading edge at the very end of the section. So there you see schematically that there's the regular slabs plus the 1 meter temporary slab at the end of the run. So much to my surprise, the contractor turned the milling machine around, right angles, and actually removed most of that rounded section at the beginning and at the end with a milling machine. I was amazed to see the accuracy of that machine. By the way, that was not one of the larger milling machines. I think it was maybe a meter wide, but it was very accurate. So one of the things we wanted to do and learn on this job was how accurate was it? So we actually checked the milled surface after it was milled. We used our standard screening device and adapted it so that we could go in after the fact, and this is hard to see, but we were able to, we stopped it at every joint, this device. First we set, if you look carefully, you'll see rails. That's our standard procedure on either side of the hole. On either side of the hole, they were set to grade. And then the screed was adopted with basically sensors that, you can see them there, that measured the actual depth at every 1 foot across the milled surface. So we did that for about 6 joints and found that the milled surface was about 12 millimeters high. So a little alarming. Contractor really didn't believe it until he set the first slab, and sure enough, it was high. As a matter of fact, the first slab was actually higher than that. So you actually come in and milled a second time. Now, the first time he sent the milling machine away, it had left, and so along about 11:30, we decided that he had to have the milling machine back. So we had to find one. Go down the road, hunt for one. He actually had one en route from another project apparently, and so about an hour and a half later, another machine and another operator arrived, and he actually milled the entire surface again. This time, rather than depending on any grade control, he actually put a string line across the hole, and he's checking it, and this time much more carefully. And he actually, believe it or not, did a very, very close job doing it this way. When we started out this job, we talked about doing micro milling. We kind of sort of did that really, although the milling machine was not one of your standard micro milling machines. So placing the slabs in the first stage, if you look carefully, you'll see in a couple other slides later on, the longitudinal edge joints were about 3 inches wide. The reason for that is we were not sure during the design phase if the milling machine would actually be close enough. In other words, if he would be wandering out of line, would actually produce a good joint. So we intentionally made it wider to make sure that the slabs fit in the hole. So we were left with a 3 inch wide space that we had to fill, so we developed, we attached some tubes, temporary tubes, to maintain traffic for the first night. You can see if you look carefully that they're setting the slab. In that first slab, there's a string line stretched across the hole, and they're setting the slab to a theoretical leading edge mark. Every slab was placed that way. Okay, so, and this is the last slab going in place. If you know our system, you know there's dowels sticking out of the last slab, so you can't put traffic on that. Of course, you have to protect it. So this 1 meter slab was fabricated. It had slots on the bottom, so it was basically used as a temporary slab to protect the dowels until the next night was pulled out and then used at the end of the second stage. Okay, so night 3, this is Wednesday night. We moved on to the grade supported slabs. This is our normal technique where the milling was milled about 12 millimeters low and to 218 millimeters. So they did that, they placed the bedding material and then the slabs, and then they started the grouting of the slabs they did the night before. So this is milling the second stage, again using the right-hand edge as a grade control. They also used a string line to check the depth of the milling machine. You can see that it took a number, I think it took 4 passes actually with that particular machine to go all the way across the hole. So as it turned out, they were still high, not high, they were higher than they wanted to be. We were still able, however, to get the bedding material in and get it graded and set the slabs. So this is actually, if you look carefully, they're compacting the bedding material. That's graded off first to, typically we grade it 1/4 inch high, and then we compact it, and then if need be, we go back and mill it again, and grade it again. But you can see that the slabs being placed on a graded surface on the right-hand side, and that took about an hour or so. At the same time, another crew was mixing and installing the dowel grout and the bedding grout behind, and the slabs were set the night before. One of the key components of the system is the grout. The dowel grout in particular, because it forms a structural connection around the dowels. If we don't have good dowel grout, we have nothing. So it's very important. There's only 2 grouts that we recommend with our system. It's typically pre-bagged, comes in like 45-pound bags. It's mixed in a mixer pump. The top section is a mixer, and then they discharge it into another hopper, and that actually pumps it into place. Okay, so if you look carefully on the right-hand side, for every one of the slots that were cast in the bottom of those slabs, which is now over the dowels, there's a grout port that allows us to actually pump grout into that slot. This is dowel grout now, until it fills the slot, fills the joint, and then that connection is filled. So they simply go from slot to slot to slot. This is a very relatively quick operation. That grout reaches, it's very important that it reach a strength of 2,500 PSI, 17 megapascals, and 2 hours. That's what we're looking for. It's hard, we must keep all traffic off the slabs until they actually reach that strength. They use the same machine, by the way, to mix and install and pump in the bedding grout underneath the slabs. So as I said before, the gaskets keep the 2 slots, the gaskets keep the 2 grout materials separate from each other. Okay, so the 3-inch space along the edge of the slab had to be filled also with permanent grout. We basically used the dowel grout, mixed it with pea gravel, we called it groutcrete, and mixed that in a concrete mixer, and you can see them placing it, and they made a plywood hopper and placed it in place with that. And that's set up in about 2 hours also. So stage 2, that was a grade supported slab, but I forgot to mention before, stage 1, the grout supported slab was done about 4:30 in the morning, and these slabs were done about the same time, actually, 4:20. So both times the slabs essentially are ready for traffic, to give you a feel for how long it's going to take to place these slabs. By the way, we like work windows from 8 o'clock in the night to 6 o'clock in the morning. There's a lot of jobs that we do in New York City and some other cities where the work window is only 5 hours. 5 hours, so we get from midnight until 5 o'clock in the morning and we're gone. And by the way, in this particular case, as with the asphalt supported, it gets open to traffic without it being grouted. They come back in the next night and do the grouting. So that is a very important little feature of this system. Okay, stage 3 was, as Stephen said, the grout supported slabs, where the slabs were put directly on the asphalt and low, and then they were adjusted upward to grade. Last Thursday night, they milled, they grouted stages 2 and 3. And yes, they grouted stages 2 and 3, placed slabs in stage 3, that's a misprint, and they completed all the grouting. The milling operation was pretty much the same. Used the right-hand edge for control, they used a string line across the opening, and they milled 218 millimeters deep, and then they tried out this little, hand milling machine to grab some high spots. I'm not sure that it was very effective, but this is one of the things that we're going to have to look at, the accuracy and the completeness of the grinding operation. It only takes one little high spot and we have a high slab. So that's something that we'll have to look at out ahead. So there's the leveling screws after it had all been installed. The leveling screws there's 4 per slab that are screwed in, and then they're used to actually vertically adjust the slabs upward to the best fit. So in this particular case, when the cross slope was varying from one end of the slab to the other, this worked out very well because you can really manipulate the slab to make it a best fit. So one of the things that happened is that they really were not prepared for this. They had a small air wrench, impact wrench. It was really too small, so they ended up doing it by hand. That guy there is a big guy, and he had a hard time doing it. What really is needed on a job like this is a very large impact wrench. That's a picture that was taken in California. Because those slabs weigh about 8-9 tons, so it takes a lot of torque to actually lift those slabs. So these slabs were in by about 3 o'clock, I think. The grouting was done by 4:30, and then of course the grout has to set up, right? You can't open it to traffic until the grout cures. So in this particular method, you have to wait another couple hours for the grout to cure before you can open it to traffic. So that's a factor that needs to be taken into consideration. So to pull all this off, really want to, I think I have this, let me just, sorry about that. So that slide was out of order, I may have to come back to that. So here's some preliminary findings, at least my findings. We're going to have a meeting here in a few weeks and try to discuss, we're going to really kind of recap this entire project. But this, in my opinion, this technology really works. It really does what Stephen wants it to do by hardening up asphalt pavement overnight. Now, all 3 methods worked. Remember, we only had one night to practice. There's always a learning curve. Contractors really never master installation until about 3 nights, maybe 5 nights before it's a finely tuned machine. In this case, all the slabs fit, that's a good thing. Generally within tolerance in terms of elevation. And the other good thing was there were no cracks. I could not find any cracks. And that's, I mean, in slabs that were used by traffic without being grouted. That's a big deal. So that was really a delight to see that when I came in the first night. So going out ahead, we really need to take a look at this deal with this cross slope variance, because it does vary. It will vary on every job, and it varies on concrete highways. We run into it all the time. So there's three things that we may consider: installing new asphalt after the precast is placed. Consider milling and filling only 1 meter, for example, next to the precast pavement. And then last but not least, you can also use, like we do all over the US, we use non-planar custom slabs, fabricated in accordance with the XYZ survey that we take at the beginning of the job. And so more accurate milling control is likely necessary, especially for the asphalt supported slabs. May want to consider diamond grinding the surface to get it smooth enough. And last but not least, of course, and this has yet to be done, I think Dan is going to be doing it, is comparing cost of each method and the performance of each method. So this doesn't happen because of one person, one company. Really would like to acknowledge Stephen's efforts. Warren Lee was heavily involved. He was very helpful. The contractor administrator was involved in some meetings that we had. Tom Kasparowski with Golder Associates really was a big help during design and in the field also. The University of Waterloo is handling the research. Dan is going to talk to you about that later on. And of course, Armtech, these particular people, Mike Price, Neil O'Halloran, and Martin Rowan, were heavily involved in this project to make it a success. And the contractor, particularly the contractor, they're very important. They can stonewall it or they can make it work. I have to say, this contractor, they were great. We were asking them, they asked them to do a lot of things that were new and foreign to them. They were very cooperative, in particular the project manager, Aaron Toth, the foreman, and the subcontractors that were involved. There was a lot of coordination that had to be done to make this happen. And of course, my associates, Mike Quaid, and our project engineer, Jeremy Snibel, who is not here. But these are the guys that deserve a lot of credit on this job. So that's the end of my presentation.